Hello, everyone. My name is Kristen Wallace, and along with my team members, Leah, Minjae, and Luna, we worked with UChicago Transportation this quarter as part of the data science clinic. Just to get a bit into some background on our project and the problem that we tackled, we worked with two mentors this quarter. Beth Tyndall, the director for transportation and parking services here at the university, as well as Nick Ross, the director of the data science clinic. Shout out to our TA Polly, and you can see the areas of study for the student team members. And our overall goal this quarter with the department was just to help them make more data-driven decisions about their UGO shuttles.
Okay. Just to kind of reiterate our goal, it's overall to just help Chicago Transportation make data-driven decisions about the eco shuttles by answering four core questions. One being reliability, which routes have high or low variance in arrival times. Our second being demand, which routes carry the most or fewest riders. Our third question is dwell, how long do buses sit at each stop? And lastly, correlation. Does greater schedule variability correspond to changes in ridership? And we hope by tackling these pinpointing these problem areas. Tackling these questions, we can pinpoint problem areas, optimize schedules, and better match service supply to rider demand. So in terms of our actual data we used, we were given two interlinked tables of operational data keyed by route, stop, and timestamp. And we were able to collect arrival and departure times for every bus at every stop, route name and stop name, boarding count, which is just how many people get on at that stop. And from these timestamps and counts, we are able to derive dwell time at each stop, which is just the departure minus arrival, headways between consecutive buses at a stop, and ridership, which is total boardings per stop per route per day. After getting these key data points, we then broke up our tasks for the quarter into three main tasks. Our first being streamlining, creating a pipeline which streamlines our data processing. Our second being creating a dashboard, which holds our visualizations and key insights, which we'll see later in the presentation. And lastly, continuing to just do more data analysis and exploration.
Before we move on to our findings, we'd like to briefly highlight some of the challenges we encountered during the project. One of the main challenges was data interpretability. Several columns lacked clear meaning, some were entirely empty, while others had identical values throughout, making them uninformative. We also faced inconsistencies in key definitions. For example, peak time was not always clearly defined on the official website, and in these cases, we had to consult with an external mentor to understand how they were classified. Lastly, all timestamps were provided in UTC, so we had to convert them to America Chicago time during pre-processing to ensure accurate analysis.
So next, we want to discuss some findings on the ridership side. So the first ridership patterns we want to discuss is the intra-month passenger load variabilities. So here we will use the 53rd Street Express route as the example. So these two graphs shows each week in the month as an individual line. So there are usually 4 to 5 weeks within 1 month. The x-axis represent the day of the week, and y-axis represent the number of passengers that get on the shuttle. So there are two main takeaways. The first one is that ridership tends to peak midweek, especially from Tuesday to Thursdays. Mondays and Fridays consistently shows lower passenger loads, which could indicate that students are more likely to travel around campus during the core weekdays. And then the other pattern we observe is there's a significant drop in the ridership during the final week, which are week 2 and week 3 in March. So that's possibly because fewer students are arriving or leaving campus in the final weeks. And next, another thing we want to analyze is the passenger load patterns for our night ride routes. So this graph shows hourly ridership across central, east, north, and south routes. So there's a noticeable increase in demand starting around 4 p.m., especially for central and east routes, which maintain high ridership through 9 p.m. So this actually shows a very clear window of peak demand during early evening hours. And interestingly, both the east and south routes hit their maximum passenger load between 4 and 5 p.m. So that's very important because Ride Smart service typically becomes available at 5 p.m., suggesting that there's still a need for night ride coverage between, before Ride Smart services begin.
This scatter plot illustrates the relationship between average daily boardings and the variability in arrival times across different UGO shuttle routes. Each point represents a route. The y-axis indicates the average number of daily boardings, while the x-axis shows how consistent the arrival times are, measured by the standard deviation in minutes. We initially hypothesized that the routes with more variability in arrival times would have lower ridership. However, as seen in the scatter plot here, our analysis did not reveal any strong or clear correlation between consistency and ridership, meaning that the arrival time variability does not directly affect daily boardings.
The second theme that we looked at, excuse me, the second theme that we looked at for the course of this quarter was the service of the shuttles themselves, starting with just the variance and the average arrival time for a given stop on a given route. And so we looked at 2 consecutive stop events for each stop on each route to see how long it took a shuttle to arrive again, essentially. And so, for example, for the downtown campus connector, the wait time that is advertised on the website is every 20 minutes for each stop. However, we found that for each stop on this route, the average wait time is actually north of 20 minutes, with the Bleacher Center being the most extreme example, with a median wait time of 41 minutes, making the downtown campus connector rather unreliable.
This plot explores how actual bus arrivals compare to their scheduled frequencies. The x-axis represents the advertised or the scheduled frequency, while the y-axis shows the observed gaps between buses. Interestingly, routes scheduled to run more frequently, such as every 10 or 15 minutes, tend to run later than schedule as opposed to routes with less frequency, meeting the schedule on average, although with more variance, as we can see from the height of the buck and whisker plots. This indicates that the buses on higher frequency routes may be arriving later than expected or being bunched at some times, leading to greater inconsistencies and potentially reducing reliability for riders.
Okay, and on to our last visualization. This is our stop waiting patterns, which is just our deep dive into how long shuttles actually wait at individual stops on a given route and time of day. So in order to actually create this dashboard, there's a couple elements to it. For one, you're able to pick a route, and for this example, we've chosen the Red Line Arts block. And then you also are able to pick the stops and a time period, afternoon, night, morning. So in terms of this spot, you see that each bar you selected is represented by a bar, and the bar represents the mean dwell time in minutes. The yellow bar is an official holdover stop, which is just a place where buses are scheduled to wait longer. And the blue bars are non-holdover or normal stops. And you'll notice that a few blue bars actually extend farther right than the yellow ones, meaning that there are some unscheduled stops that are slow, meaning some unscheduled stops are slower than our planned holdovers, and this flags to us trouble spots. And in order to, this may help us with, these may be stops that we want to target for service improvements, either by adjusting the schedule or investigating on-street delays. And that kind of wraps up our analysis visualization part of our presentation. Just to summarize our key insights, over the week, we saw that ridership peaks in the middle of the week and dips at month's end, while night ride routes were already carrying significant off-peak demand before RideSmart launched. In terms of reliability, the downtown connector's actual wait times frequently exceeded the advertised 20-minute headways, ranging from 22 up to 41 minutes, and lower frequency lines showed the greatest variability in service. And in terms of key recommendations, one, we'd probably want to recalibrate headways, and this would just be like adjusting posted schedules on high variance routes to reflect actual service intervals. Second, we'd possibly want to bounce midweek demand, and this would look like allocating additional trips or reassigning vehicles Tuesday through Thursday to smooth ridership peaks. These steps will hopefully enhance consistency, reduce unplanned delays, and improve rider satisfaction. And that is the end of our presentation. Thank you so much for listening.